Okay, so this is for second period. This is the geometry. So, kids, at the end of class yesterday, we did a very, very brief discussion on overlapping triangles. So, basically, what's going to happen here is you're going to be asked to solve for a specific side or angle and or prove that it's congruent, and you're going to do that by proving in a proof the two triangles are congruent, and then using CP, CTC. So what we want to do, so in each diagram, the stated triangles are congruent, identify their common side or angle. So each one of these, 1 and 2, is going to have a common side or angle. So what I like to do on ones like this is just trace the triangle. So that's triangle BAE, and that's triangle ABC. Well, where do they overlap? Well, they overlap in a couple places, but the only place they fully overlap is there on AB. So the answer is A, B. So using that, everyone take about 2 minutes and try and do number 2 by yourself. When the substitute is convinced that you guys have worked your best on this, then he'll hit play. So again, here we have triangle SUV and triangle WUT. What I'm going to do is sketch them out, see where they overlap. Now here they don't have any overlapping sides. While there is overlap like UT, they overlap. UT isn't actually a side of either triangle. So we just go U. So angle U is our answer. 3 and 4, they want us to redraw the triangles. So what we're going to do is we're going to draw them separately. So here's ACF. And then AEB. Now we first want to look at the sides, and they don't share any sides. So we want to look at the angles. Do they have any common angles? Well, the red one was A, C, and F. The blue or purple one was A, B, and E. So we go back and we look at them, and in fact, A is the same angle. So those two overlapping triangles then have A as a common angle. 4. Try this one by yourself. Remember, you want to sketch the two triangles separately. Figure out what their common side was. So take about 2-3 minutes for this. So, two triangles we have are FJK. So I'm going to draw that, label it. And HKJ. So every triangle has 3 sides and 3 angles. If you're ever concerned about this, what you can do is actually list them out. The 3 sides for the purple one would be FJ, FH, and JH. And the 3 sides for the red one would be JH, JK, and KH. So I said JH, it would be FK, JK, and JF. So when we're going over those and comparing the sides, we notice that JK is a side for both of them. So that's our answer. So I had a little bit of a connection problem there. So moving on. So 5. What we're going to do is developing the proof. So we have our givens. So then it says that angle FEH, that right angle right there, and angle EFG, that right angle right there, are congruent. Well, how do we know the two right angles are congruent? The right angle congruency theorem. Next, on number 3, it says EF is congruent to FE. Take about 2 minutes. Try and figure out what that is. And it is the reflexive property. Remember, the reflexive property says that one side is congruent to itself. So notice on the next step, step 4, that it says SAS. Okay, so it says side angle side. So SAS, we know, is what relates to triangles. So it means that we're going to have two triangles. So if our justification for it is side angle side, it means that two triangles are together and that the two triangles have to be length by side angle side. So between our givens and what we just proved, we have the triangles right there. Notice again they're overlapping, but we were able to use EF as a common side to prove that, and then we use CPCTC. So, number 6, I really want you guys to try by yourself. It is tough. It is going to take a while. But I really want you guys to spend at least 10-15 minutes working through this. So if you guys are here and stuck, silence, work through, check your notes, go do the back and forth. Make sure that you're looking at both sides, both columns, and go from there. So hit pause and give everyone time to work through this and then go. So the first one we have is down on step 2, and it says angle A and D are congruent to AFD. Now, the reason we know this is because we look back up at step 1 and we see that that triangle AFD is equilateral. If we look through our notes, we see something that says if equilateral, then equiangular. So if all three sides are the same, all three angles have to be the same. And that is called the corollary to the Isosceles triangle theorem. Then we have BG is congruent to BEG, and that's the same thing. 4 is given. So if you'd prefer to give them instead of 10 minutes all at once, just kind of break this up into, hey, spend 2 minutes on this, 2 minutes on this. That may be the best idea, which I said after the whole 10-minute thing. So, do as you will. So number 5, we have A is congruent to D, is congruent to B, is congruent to G. And that's just the transitive property. So we know that A and D are congruent. We know that A and B are congruent. So if A is congruent to D and D is congruent and A is congruent to B, then those two are congruent. And we just proved that B and G are congruent. So we know that A, D, B, and G are all 60 degrees. They're all congruent. It's a transitive property of congruence. So then we have EF is congruent to FE. Now, we don't really have anything, measurements or anything like that to say that's true, except for the reflexive property of congruence. So the next step, DE plus EF equals EF plus FG. So here's the thing. We know that DF is congruent to FG because that's given. And we know that EF is congruent to FE, or EF is congruent to EF. So if we add the same length to both sides, they're equal to each other. And that is simply called the addition property of equality. Because what we did is we took DE as congruent to FG, and we added EF to both sides. So the next part says the segment addition postulate. And so this is where it's really important that you know what these things are. So the segment addition postulate states that if you add two segments that are right next to each other, that length that you get has to be the same as the length from one endpoint to another. So think about it this way. If I have a meter stick and I break it into pieces and then I put all the pieces back together, it's still going to be a meter. So if I know that DE and EF are on the same line, then I know that DE plus EF has to equal DF. If I know that EF and FG are on the same line, then EF plus FG is the same length as EG. And why did we do that? Well, now, because we know that A and D are congruent, we know that B and G are congruent to each other and to the other triangle, we were able to prove angle side. So A is congruent to B. AFD is congruent to BEG. We proved that up in... well, they're both parts... steps 2 and 3, because they were congruent to the other two, they're congruent to each other, and so that gives us angle side to say that triangle ADE or ADF is congruent to BEG. That's angle side congruency. And the last one, feel free to blast off. So then we have CPCTC, and we're done. So while there is number 9 there, open-ended in the diagram above, the pattern of bend right has been designed for square floor tile. I really want you guys to try and work that by yourself, and we'll go over it on Friday. Have a great day, everybody.